Hi all, welcome back to Chemical Engineering Statistics. In this section, we will talk about regression result quality. After we do regression to our data, we need to check the quality of our regression. So how can we determine the quality of our regression? In regression, the closer the value of regression curve to the measurement data shows good regression quality. The quality is defined using coefficient of determination, or as we know as R square. From the ANOVA of the regression analysis, we can find the total sum of square. The total sum of square is partition of the total variability in the response. It divides the total variability into two components. The first one is the sum of square of error, or called as SSE. The sum square of error measures the unexplained variability in the y's, and the second sum of square is the the regression sum of square. The regression sum of square, or SSR, measures the variability explained by the regression models. We can think of the ratio SSE over SST as the proportion of variability in the response variable that cannot be accounted for by the regression model. So, 1 minus SSE over SST, or R square, is the proportion of variability in the response that is accounted for by the model. The equation to calculate the R square, or the coefficient of determination, can be found in this slide. Here we can see several examples of the coefficient of determination interpretation. In the top left figure, we can see that the regression line, or the regression equations, is close to the measured data. In this case, we can see that the sum of square of regressions is significantly higher than sum of square of error. In the top right graph, we can see that the sum of square of error is higher than the sum of square of error on the top left graph. On the middle left graph, we can see that the total sum of square is only consisted of the error sum of square. In this case, we cannot see, or we cannot find, good regression line. We can see that the R square is 0. On the right middle figure, we can see that our regression line is exactly in line with the data. This means that the R square is 1, and the total sum of square is only consisted of the regression sum of square. That's all for today. See you in the next video.